temperature is a fascinating concept in physics that helps us describe whether something is hot or cold. It is a numeric value that distinguishes these two. And what is really interesting is it turns out there really is no such thing as cold. There's heat, but there is no cold. So let's see what we're talking about. All right, let's first look at solids, liquids, and gases. Now, when you have a solid, it tends to have a fixed shape, nice edges, all right? It has very closely packed molecules. If we were to sit here and look at these molecules, they would be sitting nice and lined up. And it has very low kinetic energy. What does that mean? It means the molecules, while they're vibrating back and forth, they're not moving very much. So a solid has tightly packed molecules. P-I-G-H-T, I can't spell. Tightly packed molecules with very low kinetic energy. Meanwhile, liquids have medium kinetic energy, and their molecules tend to be a little bit further apart. Now, if you have a liquid, it's going to assume the shape of whatever your container is. And it can do that just because the molecules are further apart and they are moving a bit. Gases, however, have very high kinetic energy. They're moving a lot. They're moving in all kinds of directions. And they're very, where these were tightly packed, these are very much spaced out. Again, they will fill the container, all right? But they will fill the entire container, while a liquid will fill only part of it. It's going to fill from the bottom, while a solid is going to maintain its shape no matter what container you put it in. Now, temperature, when we talk about temperature, we're talking about the average kinetic energy. All right? It's the average kinetic energy of the molecules. So the higher the temperature, the higher the average kinetic energy. Lower temperature, lower average kinetic energy. Now, a higher temperature doesn't necessarily mean an overall more kinetic energy. Let's look at this example right here. If I have a huge bucket of water at 20 degrees Celsius and a small cup of hot tea at 80 Celsius, let's see. The tea has a higher temperature, all right? This one's going to have a lower temperature, but this one has a lot more molecules. And each molecule has kinetic energy 1/2 mv squared. So you get more average kinetic energy because you have more molecules. But there's less kinetic energy per molecule. Because it is less kinetic energy per molecule, you have a lower temperature. While this hot cup has more kinetic energy per molecule and therefore a higher temperature. So that's another way to think of temperature. Now, there are 3 key temperature scales. There are temperature scales all over the place. You can make your own temperature scale. But the 3 we're going to focus on are Fahrenheit, Celsius, and Kelvin. Now, the Fahrenheit scale is the one that you take your temperature with when you're sick. 98.6 is an average body temperature. Water freezes at 32 Fahrenheit and it boils at 212. You do need to know these 2 numbers. The second scale is the Celsius scale. The Celsius scale is one scientists used it in chemistry, and water boils at 100 Celsius and freezes at 0 Celsius. This is very nice because everything is divisible by 100 basically. It's nice, 100 nice even marks instead of this weird number. Now the scientific scale is the Kelvin scale. Anything we do, especially when we do efficiencies, must be done in Kelvin. And water freezes at 273 degrees for Kelvin, and 373 is where water boils. So you need to know all of these numbers. Now there's one more key number on the Kelvin scale. 0 Kelvin is called absolute zero. All right, and it has some significance we'll deal with later on in the unit. And if you think about what we were talking about, let's see, water boils means it has a higher average kinetic energy than water freezing. Think about this. If way down here is absolute zero, doesn't it make sense that this is the minimum kinetic energy of a molecule? And that is basically how we define absolute zero. Now let's look at our formulas. All right, you need to know these formulas. You need to be able to manipulate them. If I want you to go from Celsius to Fahrenheit, I will give you the Celsius temperature, and the Fahrenheit conversion is 9/5 C plus 32. If I give you Fahrenheit and want you to go to Celsius, then use this conversion, and it's 5 divided by 9 times F minus 32. Now, for this one, make sure you do this parentheses first. All right, whatever your Fahrenheit number is, minus 32, and then multiply by 5 and divide by 9. Celsius to Kelvin's the easiest one. You just add 273.